CIET NCERT presents Audiobook of Mathematics for Class 6. Chapter 3 Playing with Numbers.
Part 3.
Page 57. Exercise 3.3. 1. Using divisibility tests, determine which of the following numbers are divisible by 2, by 3, by 4, by 5, by 6, by 8, by 9, by 10, by 11. Say yes or no. We have a table with some columns. Column 1 says the number. Column 2 has some divisions. The heading is divisible by, and the subheadings are 2, 3, 4, 5, 6, 8, 9, 10, and 11. Row 1 has been solved for you. Number is 128. Divisible by 2? Yes. Divisible by 3? No. Divisible by 4? Yes. Divisible by 5? No. Divisible by 6? No. Divisible by 8? Yes. Divisible by 9? No. Divisible by 10? No. Divisible by 11? No. The other numbers are 990, 1586, 275, 6686, 6,39,210, 4,29,714, 2,856, 3,060, 4,06,839. All the other columns are blank. You have to think and write the correct answers in the blank spaces provided. 2. Using divisibility tests, determine which of the following numbers are divisible by 4, by 8. A. 572. B. 7,26,352. C. 5,500. D. 6,000. E. 12,159. F. 14,560. G. 21,084. H. 3 crores 17 lakhs 95,072. I. 1,700. J. 2,150. 3. Using divisibility tests, determine which of the following numbers are divisible by 6. A. 2,97,144. B. 1,258. C. 4,335. D. 61,233. E. 9,01,352. F. 4,38,750. G. 1,79,184. H. 12,583. I. 6,39,210. J. 17,852. 4. Using divisibility tests, determine which of the following numbers are divisible by 11. A. 5,445. B. 10,824. C. 7 crore 13 lakh 8,965. D. 70 crore 16 lakh 9,308. E. 10 crore 1. 5. Write the smallest digit and the greatest digit in the blank space of each of the following numbers so that the number formed is divisible by 3. A. Dash 6724. B. 4765 dash 2. Page 58. 6. Write a digit in the blank space of each of the following numbers so that the number formed is divisible by 11. A. 92-389. B. 8-9484. 3.5. common factors and common multiples. Observe the factors of some numbers taken in pairs. A. What are the factors of 4 and 18? The factors of 4 are 1, 2 and 4. The factors of 18 are 1, 2, 3, 6, 9 and 18. The numbers 1 and 2 are the factors of both 4 and 18. They are the common factors of 4 and 18. B. What are the common factors of 4 and 15? These two numbers have only 1 as the common factor. What about 7 and 16? Two numbers having only 1 as a common factor are called co-prime numbers. Thus, 4 and 15 are co-prime numbers. Are 7 and 15, 12 and 49, 18 and 23 co-prime numbers? Try these. Find the common factors of A. 8, 20, B. 9, 15. C. Can we find the common factors of 4, 12 and 16? Factors of 4 are 1, 2 and 4. Factors of 12 are 1, 2, 3, 4, 6 and 12. Factors of 16 are 1, 2, 4, 8 and 16. Clearly, 1, 2 and 4 are the common factors of 4, 12 and 16. Find the common factors of A. 8, 12, 20, B. 9, 15, 21. Let us now look at the multiples of more than one number taken at a time. A. What are the multiples of 4 and 6? The multiples of 4 are 4, 8, 12, 16, 20, 24, and so on. Write a few more. The multiples of 6 are 6, 12, 18, 24, 30, 36, and so on. Write a few more. Out of these, are there any numbers which occur in both the lists? We observe that 12, 24, 36 are multiples of both 4 and 6. Can you write a few more? They are called the common multiples of 4 and 6. B. Find the common multiples of 3, 5 and 6. Multiples of 3 are 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, and so on. Multiples of 5 are 5, 10, 15, 20, 25, 30, 35, and so on. Multiples of 6 are 6, 12, 18, 24, 30, and so on. Common multiples of 3, 5, and 6 are 30, 60, and so on. Page 59. Write a few more common multiples of 3, 5, and 6. Example 5. Find the common factors of 75, 60, and 210. Solution. Factors of 75 are 1, 3, 5, 15, 25, and 75. Factors of 60 are 1, 2, 3, 4, 5, 6, 10, 12, 15, 30, and 60. Factors of 210 are 1, 2, 3, 5, 6, 7, 10, 14, 15, 21, 30, 35, 42, 70, 105, and 210. Thus, common factors of 75, 60, and 210 are 1, 3, 5, and 15. Example 6. Find the common multiples of 3, 4, and 9. Solution. Multiples of 3 are 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48, and so on. Multiples of 4 are 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, and so on. Multiples of 9 are 9, 18, 27, 36, 45, 54, 63, 72, 81, and so on. Clearly, common multiples of 3, 4, and 9 are 36, 72, 108, and so on. Exercise 3.4. 1. Find the common factors of A. 20 and 28, B. 15 and 25, C. 35 and 50, D. 56 and 120. 2. Find the common factors of A. 4, 8 and 12, B. 5, 15 and 25. 3. Find first three common multiples of A. 6 and 8, B. 12 and 18. 4. Write all the numbers less than 100 which are common multiples of 3 and 4. 5. Which of the following numbers are co-prime? A. 18 and 35, B. 15 and 37, C. 30 and 415, D. 17 and 68, E. 216 and 215, F. 81 and 16. 6. A number is divisible by both 5 and 12. By which other number will that number be always divisible? 7. A number is divisible by 12. By what other numbers will that number be divisible? 3.6. Some more divisibility rules. Let us observe a few more rules about the divisibility of numbers. 1. Can you give a factor of 18? It is 9. Name a factor of 9. It is 3. Is 3 a factor of 18? Yes, it is. Take any other factor of 18, say 6. Now, 2 is a factor of 6, and it also divides 18. Check this for the other factors of 18. Consider 24. It is divisible by 8 and the factors of 8, that is 1, 2, 4, and 8, also divide 24. So we may say that if a number is divisible by another number, then it is divisible by each of the factors of that number. Page 60. 2. The number 80 is divisible by 4 and 5. It is also divisible by 4 multiplied by 5 is equal to 20, and 4 and 5 are co-primes. Similarly, 60 is divisible by 3 and 5, which are co-primes. 60 is also divisible by 3 multiplied by 5 is equal to 15. If a number is divisible by two co-prime numbers, then it is divisible by their product also. 3. The numbers 16 and 20 are both divisible by 4. The number 16 plus 20 is equal to 36 is also divisible by 4. Check this for other pairs of numbers. Try this for other common divisors of 16 and 20. If two given numbers are divisible by a number, then their sum is also divisible by that number. 4. The numbers 35 and 20 are both divisible by 5. Is their difference, 35 minus 20 is equal to 15, also divisible by 5? Try this for other pairs of numbers also. If two given numbers are divisible by a number, then their difference is also divisible by that number. Take different pairs of numbers and check the 4 rules given above. 3.7. Prime factorization. When a number is expressed as a product of its factors, we say that the number has been factorized. Thus, when we write 24 is equal to 3 multiplied by 8, we say that 24 has been factorized. This is one of the factorizations of 24. The others are 24 is equal to 2 multiplied by 12, equal to 2 multiplied by 2 multiplied by 6, equal to 2 multiplied by 2 multiplied by 2 multiplied by 3. 24 is equal to 4 multiplied by 6, is equal to 2 multiplied by 2 multiplied by 6 equal to 2 multiplied by 2 multiplied by 2 multiplied by 3. 24 is equal to 3 multiplied by 8 is equal to 3 multiplied by 2 multiplied by 2 multiplied by 2 equal to 2 multiplied by 2 multiplied by 2 multiplied by 3. In all the above factorizations of 24, we ultimately arrive at only one factorization, 2 multiplied by 2 multiplied by 2 multiplied by 3. In this factorization, the only factors 2 and 3 are prime numbers. Such a factorization of a number is called a prime factorization. Let us check this for the number 36. 36. 2 multiplied by 18, 2 multiplied by 2 multiplied by 9, 2 multiplied by 2 multiplied by 3 multiplied by 3, 36. 3 multiplied by 12, 3 multiplied by 3 multiplied by 4, 3 multiplied by 3 multiplied by 2 multiplied by 2, 2 multiplied by 2 multiplied by 3 multiplied by 3. 36. 4 multiplied by 9, 2 multiplied by 2 multiplied by 9, 2 multiplied by 2 multiplied by 3 multiplied by 3. 36. 6 multiplied by 6, 2 multiplied by 3 multiplied by 6, 2 multiplied by 3 multiplied by 2 multiplied by 3, 2 multiplied by 2 multiplied by 3 multiplied by 3. The prime factorization of 36 is 2 multiplied by 2 multiplied by 3 multiplied by 3, that is, the only prime factorization of 36. Page 61. Do this. Choose a number and write it. Factor tree. Think of a factor pair, say 90 is equal to 10 multiplied by 9, 90. Now, think of a factor pair of 10. 10 is equal to 2 multiplied by 5. This has been done here in the form of a picture. 90 is shown as 10 multiplied by 9. Then 90 is shown as 10 broken as 2 multiplied by 5 and 9. And finally 90 is shown as 10, which was broken as 2 multiplied by 5, and 9 shown as 3 multiplied by 3. Write factor pair of 9. 9 is equal to 3 multiplied by 3. Try this for the numbers A 8, B 12. Try these. Write the prime factorizations of 16, 28, 38. Example 7. Find the prime factorization of 980. Solution. We proceed as follows. We divide the number 980 by 2, 3, 5, 7, etc. in this order repeatedly so long as the quotient is divisible by that number. Thus, the prime factorization of 980 is 2 multiplied by 2 multiplied by 5 multiplied by 7 multiplied by 7. Below this, we see the division of the number 980 by 2, 3, 5 and 7 repeatedly, so long as the quotient is divisible by that number. Exercise 3.5. 1. Which of the following statements are true? A. If a number is divisible by 3, it must be divisible by 9. B. If a number is divisible by 9, it must be divisible by 3. C. A number is divisible by 18 if it is divisible by both 3 and 6. D. If a number is divisible by 9 and 10 both, then it must be divisible by 90. E. If two numbers are co-primes, at least one of them must be prime. F. All numbers which are divisible by 4 must also be divisible by 8. Page 62. G. All numbers which are divisible by 8 must also be divisible by 4. H. If a number exactly divides two numbers separately, it must exactly divide their sum. I. If a number exactly divides the sum of two numbers, it must exactly divide the two numbers separately. 2. Here are two different factor trees for 60. Write the missing numbers. A. 60 is shown as 6 multiplied by 10. 6 is shown as 2 multiplied by dash, and 10 is shown as 5 multiplied by dash. Write the missing numbers. B. 60 is again shown as 30 multiplied by dash. 30 is again shown as 10 multiplied by dash. 10 is further shown as dash multiplied by dash. Fill the missing numbers. 3. Which factors are not included in the prime factorization of a composite number? 4. Write the greatest four-digit number and express it in terms of its prime factors. 5. Write the smallest five-digit number and express it in the form of its prime factors. 6. Find all the prime factors of 1729 and arrange them in ascending order. Now state the relation, if any, between two consecutive prime factors. 7. The product of three consecutive numbers is always divisible by 6. Verify this statement with the help of some examples. 8. The sum of two consecutive odd numbers is divisible by 4. Verify this statement with the help of some examples. 9. In which of the following expressions prime factorization has been done? A. 24 is equal to 2 multiplied by 3 multiplied by 4. B. 56 is equal to 7 multiplied by 2 multiplied by 2 multiplied by 2. C. 70 is equal to 2 multiplied by 5 multiplied by 7. D. 54 is equal to 2 multiplied by 3 multiplied by 9. 10. Determine if 25,110 is divisible by 45. Hint: 5 and 9 are co-prime numbers. Test the divisibility of the number by 5 and 9. 11. 18 is divisible by both 2 and 3. It is also divisible by 2 multiplied by 3 is equal to 6. Similarly, a number is divisible by both 4 and 6. Can we say that the number must also be divisible by 4 multiplied by 6 is equal to 24? If not, give an example to justify your answer. 12. I am the smallest number, having 4 different prime factors. Can you find me? You were just listening to the audiobook Mathematics for Class 6. Narrator Gaurav Marva. Assistance in production Soumya Malik. Producer Vimlesh Chaudhary. Presented by CIET NCERT, New Delhi, India.